If you are working with me, miss, my level of project, whatever I am having, whatever the salary I can pay, it will be like that. That's how I can compare the same thing with the TCS. In the TCS, multiple things are there and multiple will be there. My company is a very low company and basic salaries will be there. So this purely depend on the company. Sir, this company, how much they are going to pay, you have to do the research before to that. Here the question is, you have to do the research. This is the final answer. Why I have explained all these things, miss? Before applying for that company, what is the amount they are going to give? Every company will not pay the same level. Right? So you are going to apply for the company, whatever the level you are having. Sir, I have, for example, sir, I have applied for a company, sir, that paying for me 15,000 per month. It seems. Should I join for that or not? If you feel that your worth is of 15,000, you go and join. If you feel your worth is 30,000, go and apply for 30,000 job. Who asked you to apply this one? Okay, you have got shortlisted and you have got this offer letter. But who asked you to apply for first? Before applying only, you know that salary they are going to pay 15,000. Nah? This question you have to ask before itself, that 15,000 if I get miss, should I have to join or not? Now you are going to join for 15,000 miss. Your worth is like that. For example, now here I'm the trainer in the Naresh IT. I'm having in Naresh IT and other institute, X institute. The X institute persons, they are going to pay for me 50,000. But I'm having already 80,000 salary. Then here I'm going to join in this or not? Before joining to Naresh IT I have joined 2 years back. Before joining Naresh IT, I have worked somewhere else. Now that somewhere else, whatever I have worked, from there I have shifted to Naresh IT because of salary only. Before getting the Naresh IT, I have got number of opportunities. Okay, not only Naresh IT, I will get number of opportunities. Even yesterday also I have got one of the opportunity. So like this, we are getting number of opportunities. For which one we are going to accept, miss? Which will they pay the fee? Which they're going to pay the salary, good amount of salary. Sir, some others like in Amirpet or in Balnagar, there is some institutes, sir, they are paying 25,000. Miss, why I'll go with them? Why I'll degrade myself to 25,000? The same 1.5 hour batch, what I'm training in Naresh IT, if I'm getting 80,000, the same thing I'm getting for Balnagar for 25,000. Why I'll go for them? Though 25,000 is also money only, right? But still, why I'll go? Because my capable is this one, miss. I'll focus on this. If Naresh IT, if I lost the job also, I will try for another company which is of who is going to pay 80,000 only. This is also an example. This is not the exact number. Okay, don't think this is my exact number. This is more than that one. Surely it is more than that. But I can't disclose the exact number. Right? Now, the worth, what is the worth we are having in terms of that we are going to have? So here, in term, first we have to do the EDA. Now I'm not going to apply to the, I'm going to do the research, not EDA, research. I'm not going to apply to the small institutes. I'll apply only to the top level where we can get the maximum salary. For that, what is the requirements? Obviously, when I am expecting that one, miss, their requirements will be different. When the basic institute requirements will be different and their requirements will be different. So for them, what is the requirements? I'm going to check that one. And if I'm meeting the criteria or not. If I'm not meeting the criteria, I first meet the criteria, then I will apply. Without applying, I will not apply to the company because I'm not trying for the luck. Whether they may shortlist, now luck is, let us try. There may be 80% probability that they will shortlist me. I'm not trying for lucky games. If I want to play lucky games, means I can go and play the lottery game also, right? There is a luck for that also. There is a probability that I can win the lottery. How the probability I'm having for getting the job, same way, that is also the same way, according to me. So if I'm sure on that job and job description and everything is clear, if from my end, at least I'm 100% sure, whether I may get or not, that is secondary. At least from my end, if I'm 100% sure, then I'll apply for that company. When I apply for that company, my only thing is this company has to shortlist, fix. For shortlisting, what other things are required? For that, I am going to open in the LinkedIn profile. LinkedIn, I'll see what are the previous people are working in the same company and what is their profile and what is their work and how they have designed. And according to that, I'm going to change. For this company, I'm going to try and what these people get attracted, for which things these people get attracted. According to that, I'll keep in my resume. And finally, my aim is to get shortlisted. This is my first aim. Once I get shortlisted, second aim is to get the job. First, a shortlist has to be done, right? To get the job, first shortlist has to be done. So for shortlisting criteria, what is their requirement? I have to fulfill that one, and whatever the in the job description keywords they are having, right? So one should be very good at this one. They'll write now that I will highlight. If possible, in that area, whatever the project I have done, that I will keep as my first one, which attracts the people. This is all called as research, which you have to do later. Everyone in this class has to do the research. Before applying for the company, you have to do the research. For the project, you have to do the research. For moving to next level also, you have to do the research. Then only you have to go to the next level. For doing this research itself in the company, for understanding the business problem and for understanding the data clearly, they'll give us 2 weeks of time. Without touching the Python code, they'll give us 2 weeks of time to read and to understand the data only. From morning to evening, we'll sit like this only, without opening the Jupyter notebook or Python code. 2 weeks, not 1 day or 1 hour. Clearly, you have to understand the business problem. For understanding the business problem, 1 week. For understanding the data clearly, 1 week. If sometimes data, it is some kind of pharma project or healthcare project, and we are not having any particular specialized person in our team, and we are not having the budget also for that to hire that person, we are going to, this one only increase to 2 weeks also. This purely designed at the time of project. And in the project, the deadlines will be already fixed. And according to the deadlines, we are going to work. If they have given the deadline for 1 week, means in 1 week, we have to understand. If the deadline is for 2 weeks, means in 2 weeks, we have to understand. Whatever the deadline, according to that, we have to work. We have to meet every time the deadlines. The deadlines will be decided at the starting at the project only. There will be a team, and the team is going to decide, okay, this would be the maximum time, and they will write initially itself, and they will quote the same thing to the client, and according to the budget they will take. For example, you are doing for me one project. How much time it will take for this project for you, miss? I'm going to say this project will take for me 6 months. And for this 6 months, I want this much of amount. Around 12 lakhs I want. And I'm going to give the budget like this. And if the client is okay, he is going to accept that one. Since he is accepting that 12 lakhs amount, now I'm going to start the work. This work will be done in the companies. In this way, they are going to do. Once they will discuss with the client the budget and everything, according to that, they will start. Within this budget only, everything should be done. And profit also, it should be in this only. Okay. So generally, any company, IT company, their profit will be around 30% of the project. So for example, 12 lakhs is the project budget, means out of which 3.6 lakhs will be the companies, and remaining 8.4 lakhs, whatever the 8.4 lakhs is there, that they are going to spend for that project, for the salary purpose, or for the infrastructure purpose, or for current bill purpose, whatever it is, they are going to spend remaining 70%. 30% is profit for the company. Now, if you increase to 30 to 35%, if you try to increase, they'll get some kind of crores amount. Now, automatically, they are going to give us as a project manager. Next level. They are going to make it as promotion. If we are completing on time or within the low budget, means automatically more promotion will be there. For example, if I complete a project of 12 lakhs, okay, one person has given me 12 lakhs project and I have completed on time. Next, second time, he'll give once again the same 12 lakhs or 10 lakhs approximately. Again, I have completed this one also on time without saying any excuses. Arey, sorry, I am not feeling well, Ra. My mother is not feeling well, Ra. And we went to hospital. This type of stories we should not say. Though you are having really the problem also, you have to do your work. Well, for them, it is completed on time or not on time. That's it. They are going to see. For example, if you have told some kind of story, what happens? Okay, this project will be completed, but no further projects. For the temporary purpose, it is solved. Okay, but furtherly, there will be nothing. In the company also, if you say continuously excuses, your project manager gives some deadlines and you are saying some kind of excuse, sir, please, this was not completed, sir. Tomorrow I will complete. Sir, I will complete in 2 days, sir. Sir, here I have came to my hometown, sir. Sir, I'm in the traveling, sir. Sir, yesterday bus has cancelled, sir. If you say like this silly reasons, Though everything are correct only. I'm not saying that is false or you are lying or something like that. Everything are correct only. You don't know proper planning and you don't have everything according to that. Finally, you have done like this. Till that project, they'll keep silent. After the project, Shiva, please, can you see another company? They will say like this. Till that project, they'll not say anything. If they say immediately means it is going to impact on that project, the present project. After the project, they will say that if they are close to you means directly they will say, please go and check any other company. If they are not close means they will say to another person and that person will come to you and he will say. This is the thing. Here yes or no only will applicable. No stories will be applicable. Have you completed the project? Yes or no? For example, you have completed without saying any kind of story. First project completed, second project completed. Automatically, third project you are going to get 30 lakhs. So third, fourth project you will get somewhat more, somewhat more, somewhat more. Like this, you are going to increase the level of project. The same IT companies, startup companies are going to become to the next level like this only. Every company when they have started initially, Wipro has started initially as a startup company. What is the Wipro miss? Initially they have taken the projects. What is HCL miss? Initially they have taken the projects. What is TCS miss? Initially they have taken the projects. Every company is a startup company by default. Slowly they have improved to maximum extent. Now, which is of worth of TCS itself? 1,76,000 crores. Where the basic level to 1,76,000 crores, the project worth. Sorry, the market capitalization worth. So here you have to do the research, the data understanding you have to complete before itself. And after doing the data understanding, EDA. EDA means you have to clearly see that how many missing values are there. Only how many. Question is how many only. Not how to treat. Just observe how many are there. How many columns are having outliers. Outliers with how many columns are having. How many columns are having missing values. How many columns are skewed? How many columns are with respect to this ordinal data? How many columns are ordinal data? Okay, nominal data, how many are there? Ordinal, how many are there? And what is the shape of the data? Okay, in this, how many continuous variables are there? How many discrete variables are there? First, you are going to complete the question of how many. Everything is done. Now you are going to do some kind of plots, followed by plots. Now after the plots and this one, now you analyze the given entire data. Analysis is done. Analysis of the complete data was done, which we used to call as descriptive analytics. Descriptive analytics means what are the data they have given to you. You are going to work on that, which is called as descriptive analytics. You are not going to do any modification. You have just observed only, but no modification. What are the observations you have drawn? Sir, here missing values, these many columns are having missing values. Write the number. These many columns are having outliers. Write the number. And the column name. Column name and the number. You are going to write everything in the Jupyter notebook in the either in the markdown cell or you are going to write in the PPT separately. So in the given raw data, we are having these many missing values, these many outliers, and this thing, like this you are going to do. And you are observing, and finally you are going to make the plots. And from this, you are going to analyze completely whatever the data they have given to you, raw data you are analyzing, which is called as EDA. This process will take at least 2 to 3 weeks of time in the company. Not the data is given and immediately within 1 hour, we are not going to submit the project. The project is going to be of 4 months, which is of almost 16 to 17 weeks. Right? 4 months project means it is going to be at least we are having with respect to the time is 16 weeks per month, 4 weeks and 16 weeks we are going to have. Right? So now whatever the project we are going to do for 16 to 17 weeks of project, now in this 4 months, they are going to divide for each part. In that EDA part. EDA is only for the past data. Now after this, you are going to start the data cleaning and data wrangling. After once this is completed, you are going to do the train test split. Next, you are going to come to the modeling. Simply taking the data, directly entering into the modeling, fit with X train, Y train, there will be no use. Because while interviewing, I have interviewed multiple students. While my interview process, I have observed that what you are going to do means, sir, we are going to take the data, sir, and we are going to give the model, sir. They know directly what I have to do in the fifth week. First 4 weeks, they don't know what to do. And in these 4 weeks only, everything, the fundamentals, without knowing the fundamentals, they know advanced part itself. Now, without knowing the fundamentals, if they say that I know the advanced part without knowing the fundamentals, are you going to select that type of students? Simple. We feel that these people are not having any fundamentals. Future, we are going to have some kind of problem. Temporary purpose might be solving, but in future, these people will have problem. So we are not going to select this type of people. So we want the fundamentals very strong. Means we are going to ask the question, what you are going to do in the project. Means you have to explain very clearly the project, whatever the steps you have involved. Okay. When they ask you the question and you know the maximum answer in that, give the maximum. Don't eat off half of them. Okay. So give the maximum answer. Whatever you can give for that particular question, give the maximum answer. Then they will understand that this was done by you. If you have given only part of the answer, then what they will understand is this was copied from the internet or this was taken from others. In simple answers, if you take, they will understand like that. If you give maximum answer, then they will understand, oh, this much of lengthy he is saying is this person has done the project. Then only he is explaining the lengthy process completely. Who will explain the lengthy process means who has done the project. Who has copied the project, they will not explain the lengthiness. Simply they will cover off in one shot. Right? So here we are going to do that. First one is formulate the problem. For the given problem, formulate. And here we are going to do within the regression, we are going to fit the model. Means we are going to train the data with machine. We are going to give to the machine and we are going to train. And for the linear regression, we have to do the validation of assumptions. Only for linear regression. Why? Because linear regression is purely an assumption. We are assuming the relation between X and Y is linear. That is our assumption. Okay? The relation between X and Y is linear is an assumption. We are assuming. Sir, why we have to assume? Why we have to assume? Because this is the simple one. Since it is a simple one, we assume that the solution is very simple and we'll start the process. Okay, that is the reason linear regression is an assumption. Purely regression itself is an assumption. And we are assuming that it satisfies the linear regression itself. So that is the reason we have to check the assumptions for only linear regression. Whereas other models, there is no assumptions. You don't need to validate the assumptions. For linear regression, you have to validate the assumptions. This is extra. Now, if the validation of assumptions are also okay, then you have to proceed to the next level. That is evaluation. If the evaluation is okay with the client requirements, then you have to stop. Otherwise, again, you have to rebuild the model. So, for example, I have got 90% accuracy, sir, but assumptions are not met, sir. Worst model. Assumptions has not met, but accuracy is 90% also worst model. There is no use of that model. Okay. You can't give this model for deployment. You can't submit to the client. Assumptions should be validated. Test accuracy and train accuracy should meet the client requirement. Then only you have to give to the client. Right? Now, so in simple linear regression, we are going to predict the value of Y based on another variable X. Means by considering only one X variable, we are going to predict the Y variable. X is called as independent variable and Y is called a dependent variable. Why it is called as simple means because it examines between two variables only. One X and one Y. Only two variables you are having. Why it is called as linear means we are going to assume that the independent variable increases or decreases in a linear fashion. As the X value increases, Y also increases in a linear way, or X decreases, Y decreases in a linear way. Either in a positive direction or negative direction. Any direction, okay, but in a linear way. Okay? In a linear fashion, assumption, that is called as linear regression. So here you are having the data with respect to x variable and y variable. And you are going to fit with respect to a line which is called as regression line. Okay. And this regression line is used for predicting the values. So first what we are going to do is, first we are going to start the linear regression by scatter plot. First step is scatter plot. In the scatter plot, we are going to observe what is the between y versus x. The scatter plot between y versus x. If I am having multiple input variables, y versus x1, y versus x2, y versus x3, y versus x4, like this. Between output variable versus that input variable, I am going to take each and every scatter plot. Sir, I have to write multiple codes, miss, no need. Pair plot is there, na? In the pair plot directly you are going to get everything, na? So from the pair plot itself we can observe everything. In one shot we can complete everything, observation. You will see. If it is a simple linear regression, we are going to apply the scatter plot. If it is a multiple linear regression, we are going to apply the pair plot. And we are going to observe the scatter plots. But the scatter plot you have to observe only between the independent versus dependent variable, not between dependent versus dependent, not between x1 and x2. You have to observe only between y and x. Now you are having y and x like this. Now from the scatter plot, you have to say three things. One is, from the scatter plot you have to observe three things. One is whether they are in the linear. Means the scatter plot looks like in terms of like this, in terms of like this, or the scatter plot looks like this. The data points are like this, or the scatter plot looks like this. Some data points will be like this also. Now in this case, it is not linear. It is a non-linear. Shape is like this. In this case, curve is like this. In this case, it is like this. So that you have to observe in the scatter plot. Okay. So if you have observed this one, then you have to apply the linear regression, assuming that linear. If you have observed this one, you have to go with the polynomial regression, non-linear regression. Anything apart from straight line, anything you have observed also non-linear only. The only straight line is called as linear. Is that clear? This is the first step one you have to understand. The second one you have to understand is in terms of direction is positive direction or negative direction. You have to observe the direction. Direction means from here to here, the x value increases. This is the basic x value. For this x value, this is the y value. For this x value, this is the y value. For this x value, this is the y value. For this x value, this is the y value. For this x value, this is the y value. Now, as x increases from here to here, y increases from here to here. As x increases, y increases, or x increases, y decreases. Means in terms of in a scatter plot, you are having the direction like this, or you are having the direction like this. Downwards. If it is downwards, means negative direction. If it is positive, means positive direction. Now what is the difference between these two? Means the slope is positive, the slope is negative. That is, only difference is slope. Slope value is going to be negative. Slope is negative means that indicates that as the x value increases, y decreases. Example is mileage of a bike. If cc, 100 cc, 120 cc, 150 cc, 180 cc. For 100 cc, the mileage will be very high. For 120 cc, the mileage will drop. As the cc increases, it is going to drop. For positive example is experience versus salary. As your experience increases, salary also increases. It is not going to drop. If you are in the same area, same domain, means automatically. If you change the domain and then again it may be difference. If you are in the same area, automatically everything will increases. Right? Now, here we are having with respect to like this equation. So generally straight line. What is the straight line equation is y is equal to mx plus c. The same thing you can write as y is equal to ax plus b. The same thing you can write as with respect to beta b1x plus b naught. The same thing you can write as beta 1x plus beta naught. The same thing you can write as beta naught plus beta 1x. Anything is same only. If you observe, anything is same only. In this case, this is called as slope. 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 This is called as intercept, 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 intercept. Equation is same. Slope into the variable plus intercept value. Y is equal to slope into the variable, whatever the variable, plus the intercept value. Intercept value. This is the equation. Now what is the difference between y is equal to mx plus c and y is equal to ax plus b is notation. That is called as notations. The notations will be differ from person to person. You are going to take in one type of notation and I am going to take in another type of notation. But concept is same. If you take y is equal to mx plus c or y is equal to ax plus b, both are same. The notation is different. Sir, why these notations are different means, in your schooling, for example, you have studied with respect to how to divide 10 with respect to 2 means, you have, some people will take like this. They'll write like this. And they'll write something like this and they'll do. Some people will do like this. Okay. Each person is going to write in a different way. So for example, if you ask me, sir, what is the, for 19 into 20? You ask me like this. Now one person is going to do 19 into 20. He'll write like this, 0, 0, 18 and 1 like this. What we are going to do is 20 minus 1 into 20. 20s are 400, 400 minus 20, which is 380. This is one way. This is one way. Which is correct, which is wrong is? Both are same answers only. The way is different. The way you have prepared, according to that you are going to practice and according to that you are writing. The same way the notations also in each country that they're followed in a different way. If you take in a different textbooks, different notations will be there. Okay, first time when I am preparing, in India, I have prepared in my maths with respect to y is equal to mx plus c. One day I have opened one maths textbook which is author is US author, and I have opened their equation. They have written the equation in terms of y is equal to some kind of not mx plus c. They have taken some other thing. Like what is that equation is? Just a minute. Mx plus b. Their equation is mx plus b. I was confused. What is this b? Suddenly I was confused. What is this b? So then I have opened in the starting pages, first page notations will be there. In the tabular, that is table of contents, after that observations is the word will be there. And then they will write everything. There I have observed what is meant by b means. They have written that y is nothing, b is nothing but y intercept is sims. Oh, they will take b also y intercept. Then I understand. So notation is going to be differed from person to person, but concept is same. For them also y the same equation. It is not going to change the equation. The equation will be the same. Notations only will be different. Right? Now here, in the machine learning, within the machine learning, the same thing, whatever we are having, okay, whatever we are having in the machine learning, y is equal to, we are going to say as beta naught plus beta 1 x, which is nothing but beta naught is the intercept variable and beta 1 is the slope. So beta naught is nothing but intercept, y-intercept, and beta 1 is nothing but slope. Slope is also called as coefficient. Coefficient in machine learning, it is called as coefficient. And intercept is called as constant value. Okay. One is called as coefficient value and one is called as constant value or intercept value. Anything is same. Right? Sir, these many things I am getting confused, sir. You are saying multiple things and multiple equations like this. I am getting confused. Miss, if whichever equation you are feeling easy, remember that one and forget all remaining of. Okay. So in your brain, there is not that much of capacity, miss. Remove. How we are going to remove in the pen drive? If there is no space, miss, how we are going to remove in the same way? Simple. Right? Just remove which is unnecessary things. Okay. So just here it is y is equal to beta naught plus beta 1 x. Now here what we are going to do is we are going to identify the relation by linear, by substituting in this equation. So now I want the relation between x variable and y variable. The equation should be in terms of y is equal to beta naught plus beta 1 x only. In this format only it should be there. where the beta 1, beta naught and beta 1 you have to calculate. I'm not going to fix the values. I'm going to fix the equation. Equation is fixed. So now, for example, I'm having 1, 2, 3, 4, 5. And here I'm having the values of 11, 12, 13, 14, 15. Now you have to tell me the equation only in terms of like this, where the beta 1 and beta naught and beta 1. That is, you are going to say that y is equal to here x plus 10. Now in this case, what is the beta 1 value is 1 plus beta naught is 10. That's it. I want in this term only. In this way only I want. Sir, here it is satisfying. So in this way you have got. For example, here you are having 14. This is 12 only. This is 18. This is 19. And this is 15. Now, in this case, what we are going to do? There is no perfect equation, but still I want in this way only. Still I want in this way only. But beta naught and beta 1, you have to calculate. Sir, how I have to calculate, sir? There is no perfect equation now. Means you have to try with equation which gives the sum error as minimum. Here we are going to focus on which equation gives the error minimum. You have to try the equation. The equation should be in such a way the error should be minimum. For example, you are substituting 10 plus 4x. Assume. Why I have taken 10 plus 4x also, I don't know. Just example. Okay. 10 plus 4x. And you are going to get some predicted, these are the y predicted values, and y hat is equal to this time 5 plus 2x. Second time, you are going to try 10x plus 1. Third time, you are going to try y is equal to x plus 14. Like this, you are going to try in a different equations. Now, out of this one, these four, only you are having 4. Out of these 4, which is the best one, miss? Which has the error minimum? That is the best one. Okay. What is the best one, miss? Best equation, best line. Equation is nothing but line. So, equation or line, best fit line. Best line is which has the error minimum. The line which has the error minimum, that is the best one. Okay. So I will explain with the example clearly, and I am going to take from the start to end mathematical calculations, theoretical calculations, and followed by practical, that is Python code. Right. So let us see first one, how it is going to work on the principle called as ordinary least squares. So you are going to get the error. I have told you that y and y hat. Now this y hat is you are going to predict and you are going to calculate the error. That is y minus y hat. Y minus y hat is called as error. Now whatever the error you are having in each of them, now which error you are going to focus? Which error means here for each record one error will be there. Which record you are going to focus means you are not going to focus on individual record. You have to take the average error. That is y minus y hat, sum of the y minus y hat divided by n. Average error. Now, sir, in this, some of the errors will be positive and some of the errors will be negative. Then automatically it will be squared off. Na? Then what we are going to do is, we have to convert that error to some positive value. How to convert the errors to positive value is, one is you can take either absolute value, one is either you can take the square value. Y minus y hat either absolute or y minus y hat whole square, any one. If you consider this absolute value, then it is called as mean absolute error. Mean absolute error. What is meant by mean absolute error? Means first you are going to calculate the error. So, sir, let me explain with an example. Okay. Yeah, let me take an example. Write in your notes. After understanding, you write in your notes. If you, I will give you the time to write entire things. First, you focus on the board. If you want, you can take the photo also. You can take the screenshot also. Everything, right? If you're not able to write, miss, you can take the photo also. But focus on the concept is important, right? So here I'm having x values and y values. Two values I'm going to consider. That is 1, 2, 3, 4, 5. Right? Now I'm going to take here 11, 18, 12, 16, 20. Something I have taken like this. right? Now what I'm going to do is I'm going to take y is equal to beta naught plus beta 1 x, out of which beta naught is 2 plus not 2, 10 plus 1 x, assume something like this. Now what we are going to do is we are going to calculate the predicted value. First you substitute the predicted value here, that is first one x value, substitute the x value here. What you are going to get? 10 plus 1 11. 2 you substitute here, 10 plus 2 12. Next you substitute 3, 10 plus 3 13, 10 plus 4 14, 10 plus 5 15. This is called as predicted values. Predicted values is nothing but this is called as your model. Model dot predict is the code. Python code is model dot predict. We don't want to focus on the what is the backend code of this miss. You are going to substitute each and every value of x in the given equation. The meaning of this is that model dot predict of x miss, the meaning is substitute values of x and calculate the y values. That is the meaning. Okay, substitute the x values and calculate the y values, and I have calculated. Now this calculation, whatever the values I have got, this was given by the machine. This is the actual data and this is the predicted by the machine. Since it is predicted values, I am going to write as y hat. Y hat is nothing but predicted values by the machine. Predicted values by the ML algorithm, whatever the ML algorithm. Here simple linear regression algorithm. So simple linear regression, whatever the equation I am having, this algorithm has predicted these are the values. Y hat is nothing but predicted values by the ML algorithm. Now, if you calculate the y minus y hat, now 11 minus 11, 0, 18 minus 12, 6, 12 minus 13, minus 1, 16 minus 14, plus 2, 20 minus 5, plus 5. Now in this, minus also is there. One is minus is there, some of them are positives are there. Now, if you take the error, total of the errors, the negative values, for example, let us assume this was instead of 8, let us go like this. This value is instead of this value. Let us take, predicted value is going to be 11 only. The actual value, I'm going to take it as 7, 13. 13 means, here in the y variable, it is minus 2. Minus 2, minus 13, you have got something like this. Okay, minus 2, minus 11, it is minus 13. Now, if you do the total, automatically it is going to be 0. 0 means no error. If you total is sum of y minus y hat is nothing but 0. 0 means what is the meaning of 0? That is no automatically sum is 0 means automatically average also 0 only. Average is also 0 only. Means average is 0 means there is no error. For this particular data, there is no error. Average error is 0 means there is no error. You are saying indirectly there is no error. Here there is no error. Every record is having the error, right? Now, how to calculate then? Means what we are going to do is here, that is the reason we are not going to focus only on the average error. We are going to take the next one called as y minus y hat absolute value. Now everything we are going to convert to positive 0, 6, 13 to 5. Now if you do that summation, that is y minus y hat absolute value summation, which is nothing but 6 plus 13, 19, 19 plus 2, 21, 21 plus 5, 26. Now if you take the average, that is y minus y hat absolute values, whatever the absolute values you are having, for this you are doing the average value, which is 26 by 5, which is 5.2. This is called as mean absolute error for this particular model. For this model, this is the mean absolute error. Similarly, for this model, for the same model, if you calculate the y minus y hat whole square, that is this one, 0, 36, and 13 square is 139, 2 is with respect to 4, and 5 is 25. Now, if you calculate the total of this one, that is summation of y minus y hat whole square, if you calculate, that is 36 plus 139, which is equal to 175, 175 plus 4, 179, 179 plus 25, which is 204, right? 204. Now, if you take the average value, that is summation of y minus y hat whole square divided by n, which is nothing but 204 divided by 5, which is equal to 40.8. Huh? Oh, why this is 169. Huh? Okay, so you have to add 3. That 234. Total is 234. 234 divided by 5. So 234 divided by 5, what is the value? 4 and 6.8, 46.8. Right? So now this is called as mean square error. Whatever the error is there, that error you have done the square. After that, you have applied the mean. This is called as mean square error. Now, out of these two, which one I have to consider? Mean square error or mean absolute error? Means you have to go with mean square error. Why, sir? That is the question. Because we want error to be minimum. The errors, whatever the errors are there, the errors should be minimum. Minimum is we have to apply the differentiation, and d by dx of error, if you calculate, for absolute values, it is going to be infinite. So that is the reason we are going to take this one. Example is d by dx of modulus of x is nothing but mod x is nothing but x by mod x. At x is equal to 0, what happens means it is going to be the infinite. The solution is infinite. Whereas the same thing, a divided by dx of x square is nothing but 2x. The same thing at x is equal to 0, it is now equal to 0. So that is the reason we are not going to take the modulus. We are going with square. Sir, what is the calculus I require? Miss, if you understand this equation is more than enough. This is the only calculus we require. This is the interview question. And out of 100, one people will answer this one. They know what is mean absolute error. They know what is mean square error. But they don't know why we are considering the mean square error as the main one. Why? The reason behind is the differentiation problem in the mean absolute error. That is the reason we are never consider absolute values. I have even explained the same thing in the variance also. During the variance and standard deviation explanation, I told you why the square has came into picture. Right? Now, similarly, but sir, if you observe this one, you have done the square means automatically the values has been increased. And that too, here y hat, you are predicting something. For example, your y hat, original y is 11 lakhs, 18 lakhs, 2 lakhs, 16 lakhs, 20 lakhs, some lakhs is there. You predicted also 11 lakhs, 12 lakhs, like this you have predicted. Difference also with respect to lakhs only. Okay. Now it is going to be the lakhs square. Now the units are getting squared off. When you are doing that one, units are also getting squared. Automatically, you are going to say 46.8 L square. I don't want L square, I want L only. Because we are predicting L only, not L squares we are predicting. So then what you have to do is root of this. You have to apply the root of this. Root of sigma of y minus y hat whole square divided by n, which is called as RMSE, root mean square error. This is the one which we are going to consider. Is that clear now? So, just you can take the notes or whatever it is. If you can take the notes, take. Otherwise, I'll take the screenshot and I will upload in the drive. Should I upload? So this screenshot will be uploaded in the drive, and after tomorrow it is going to be deleted. Why, sir? Because the same is going to be for other batch also. The same drive link is there for other batch also. The same example is not for them. This example, which example I have taken for them, I don't remember. I can't remember the examples because the same values I'm not going to take for everyone. Randomly, we are going to take some values and we are going to apply the concept. Okay. At that particular time, whatever the numbers I get, that I will apply. It is not fixed numbers, this one only, and this is the same example. If I upload the same thing in the drive and if I keep miss, what other batch students will think that sir has not explained this one. Their notes and their drive, both will be mismatched for them. Some people will write running notes. Na? For them, it is going to be mismatched. So that is the reason I'm going to delete. So before deleting, I'm going to give you for download option. You please download. Okay, you happily can download. Not a problem for me. I'm going to upload in the drive. The same screenshot I'm going to upload in the drive. Right? Yeah, Swati is asking, sir, how to predict the slope and intercept values. That is the thing which we are going to see. How to predict that one only we are seeing. Right? Now, if you are having that one, now what is meant by ordinary least squares? The linear regression works on the principle called as ordinary least squares. Okay? Which is also called as OLS technique. Ordinary least squares or OLS. Yeah? Yeah, Robin is asking, sir, how the slopes are decided. Yes, that one we are going to see. We are going to observe. Just hold on. Okay, so here we are having ordinary least squares method, which is also called as OLS technique. Now for this data, this is the data. Now for this data, you are having 5 data points are there, and this is the scatter plot. Now in this, you can draw this line, 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 you can draw this line. Like this, you are having multiple lines. Multiple lines are there. Out of all these lines, which is the best one? Which line is the best one? Means which line gives you the sum of the squares of errors as minimum? That is mean square error is there, na? The mean square error or RMSE. We want RMSE. This should be the minimum. The error should be minimum. What is this mean square error? Means nothing but sigma of y minus. So once again, clearly please observe this one. Mean square error. Don't by heart the formula. What is meant by this MSE is mean square error. Don't by heart the formula. First you write the error. This is y minus y hat. After that, what is the square is there? Write the square. After that, mean is there. Write the mean. Calculation also same way. First you have to calculate the error. After that, you have to calculate the square. After that, you have to calculate the average value. This is called as mean square error. Now in this mean square error, now the denominator is n. For example, you are having first equation. That is first line like this. Second line like this. Third line like this. Fourth line like this. Each line is going to have different beta naughts and beta 1 values. Now for the first one, you are going to calculate the MSE. For the second one, you are going to calculate the MSE. For the third one, you are going to calculate MSE. And fourth one, MSE. Out of all the MSEs, which MSE value is less? Now the MSE, whatever the MSE is there, this MSE is nothing but denominator is constant, right? Some number only. It is constant. If you focus only on the numerator, this error should be minimum. The above one is called as sum of the squares of errors. SSE by n. SSE means sum of the squares of errors. You are just doing the sum without doing the average. Just you are going to do the sum. Our focus is sum of the squares of errors should be minimum. Now for this particular scatter plot, which line is the best one? Miss? Which gives the sum of the squares of errors as the minimum. That is the best fit line. That is the best line. Right? So here we are going to consider the best fit line. So here we are going to see, let us assume this is the line we have taken. Now this is the actual value and this is the predicted value. Predicted value is nothing but on the line, whatever the value is there, that is the predicted line. Because by substituting this x value, you have got the y value. By substituting this x value, this is the y value. By substituting this x value, you have got this y value. By substituting this x value, you have got this y value. By substituting this x value, you have got this y value. Whatever your y values you are going to get on the equation, y is equal to earlier x plus 10, I have told you now. This equation, by substituting different x values in this, and you are going to have that one. These points, if you make, and if you make a line over that, that is called as prediction line. That line is called as prediction line. Okay? Prediction line. This prediction line, we want with respect to the best one. So you are having this one, this one, this one, like this. Multiple prediction lines are there. Multiple slopes with intercept values, combinations are there. Infinite are there. Out of infinite, we are going to identify which is having the sum of the squares of errors. So you are going to calculate the error, that is y minus y hat or y hat minus y. Anything is okay because anyways you are going to take the square or absolute values only. So there is no difference. So you want the sum of the squares of errors should be minimum. That is called as OLS technique. OLS technique means ordinary least squares. Least squares means squares should be least. Which squares? Error squares. Error squares should be least. That is the meaning of ordinary least squares method. Is that clear now? Online, Robin and one more Swati. Is that clear? Now, which one is we are going to decide? Which equation means the equation which gives the sum of the squares of errors should be minimum. That equation. For this is the one line. Okay, this is one more line. For this line, different slope will be there, different intercept will be there. For this line, different slope, different intercept. For this line, different slope, different intercept. For this line, different slope, different intercept. Different slope, different intercept. Different line, like this you are going to have. For each line, you are going to calculate the sum of the squares of errors and which gives the minimum, that is the best one. Now, sir, okay, infinite lines are there now. Are we going to try all the infinite lines? Is that manually possible? It is possible. It is possible, but it will take more time. How it is possible means you have to apply the while loop, while true. That is infinite loop is there now. If infinite loop is there, infinite times we can have. Wherever the best answer is there, then we are going to apply the break. Best answer, break. Worst answer, continue. Right? So, but it is going to take so much of time. So, we are going to not apply that type of things. We are going to do in here, the calculus comes into picture. What is the calculus is nothing but what you want minimum. Which one you want minimum? Any equation, write whatever the favorite equation you want. For example, 2x square plus 9x plus 4. For this, what is the minimum value? You want to calculate what is the minimum value for this. dy by dx.